As the conversation around artificial intelligence intensifies, the labels open source and closed source frequently mentioned. While open source suggests transparency and accessibility, closed source implies exclusivity and control. But in the realm of AI, these terms might seem displaced. But why? The definition of open needs reconsideration because the technology operates fundamentally differently. In traditional software, a team of developers writes the code, and this code will instruct the computer on what actions to perform. In contracts, when creating an AI model, known as a foundation model, like a GPT-4, developers are feeding large volumes of data into a computer, which autonomously is identifying patterns and calculating weights. And this process, though, is training. It's computationally very intensive, hey NVIDIA, forming the core intellectual property of many AI technologies. The simple view of the process of building a foundation model is developers write an initial code that dictates how the model learns. But during the training process, the computer calculates and adjusts its weights based on the training data. It's really like the computer is writing the code. And these weights are what allow the model to perform tasks, such as answering questions and generating text. Essentially, the higher the quality of the weights, the better the model. A bit confusing, I know. Let's take a deep breath. Let's use an analogy to understand this relationship between the source code, the data, and the weights in Gen AI. Let's use a recipe of a cake. The source code would be the recipe. The data would be the ingredients, and the weights, the measurements of each ingredient. So the recipe provides a detailed instructions on how to mix ingredients, how long to bake them, and the order of addition. Similarly in AI, the source code defines the structure of the model, including the number of layers, the types of layers. There are a lot of videos on neural network models if you want to get technical. Coming back to our cake. The quality and variety of our ingredients, like flour, sugar, and eggs, will influence its taste and texture, just as the quality and diversity of the data used in training the model. Lastly, the proportions of flour, sugar, eggs are critical for a cake success, just as the precise calibration of weights in an AI model is crucial for its effective function. And if you think about, whenever you're baking a cake, you're actually buying new ingredients, but the weights will always stay the same, with some personal tweaks, depending on whether a person wants more sugar or less sugar in any given day. And even if you use the best ingredients, you can only achieve so much if the proportions are incorrect. That's the importance of the weights. And sorry, we had to spend some time in training data and weights because when referring to open source AI like GPT-4, sharing the source code is not as crucial as sharing the weights and the training data. Let's go through each of these. The source code. In open source AI, the model architecture is available for anyone to view, modify, and distribute. And these models are going to be usually in open source frameworks, which Google has TensorFlow and Facebook has PyTorch. The model weights. This is crucial. The weights are what enable the models to perform tasks. They encode the knowledge the model has learned during training. Linguistic structure, world knowledge, word patterns. Third, the training data. This is almost always very sensitive. The weights learned by a model are directly depending on the data used training the model. But what data was that? Are companies using public and available information or personal information or artist life work? The Wall Street Journal asked OpenAI CTO Mira Murati about this in March 2024.
What data was used to train Sora?
We used publicly available data and licensed data.
So videos on YouTube?
I'm actually not sure about that.
Okay. Videos from Facebook, Instagram?
You know, if they were publicly available, publicly available to use, there might be the data, but I'm not sure. Yeah. I'm not confident about it.
What about Shutterstock? I know you guys have a deal with them.
I'm just not going to go into the details of the data that was used, but it was publicly available or licensed data.
Interest response, huh? Also important is the quality and diversity of the training data. Poor data quality or lack of diversity can lead to models that are less effective or that perpetrate bias present in the training data. Open source projects might use publicly available or especially curated data sets. So in summary, while having the model weights is crucial, the data used for training these weights is equally important because it fundamentally shapes what the model knows and how it responds. Because open source AI has not yet been fully defined, a task that Open Source Initiative began driving in 2022, it's crucial to evaluate claims by companies about their open source AI. What actually has been released? What a developer can do with this release? In an excellent paper called The Gradient of Generative AI Release Methods and Consideration, Irene Solomon, who is the head of global policy at Hugging Face, proposed a framework with 6 levels of openness, discussing the pros and cons of each. As she put it, a strict, closed, and vertical process to commercialization can lead to concentrated power among high-resource organizations. An open process without ethical considerations can inflict and exacerbate risk and harm from misuse to bias. She categorized 3 components of an AI system to evaluate its degree of openness. The first category is access to the model itself, which includes the model weights and the ability to query, adapt, and conduct research in the model. The second, components that enable further risk analysis, such as the training data, fine-tuning data, and system risks. And lastly, components that enable model replication. These components include a technical paper, the model training process, and the code used to train the model. These components may be withheld because of competition, IP, and misuse reasons. And here there is a risk, because if these components actually get into the hands of malicious actors, it can be replicated for harmful use cases. In her gradient of system access, you're going to see the 6 different levels of openness: fully closed, gradual staged release, hosted access, cloud-based API access, downloadable, and fully open. And you're gonna see here that these models were released, they're not the latest. These were released from 2018 to 2022. That's why Llama 3 is not here. And you're gonna see the trade-offs along the gradient. As systems become more open, they better enable audits, community research. But on the other hand, they have a lower risk control compared to the fully closed, that you're gonna have a higher risk control, but limited perspectives, low auditability, and just allowing for internal research only. The debate around open versus closed source in AI centers around this trade-off between concentrating power and mitigating risk versus transparency and innovation. In our next video, we'll talk about how the big players like OpenAI, Meta, and Google are approaching the open versus closed debates. The best way of learning is by asking. Until our next But Why.